Welcome to Webinar Wednesday. On behalf of the Powder Coating Institute, thank you for joining us for today's webinar, Automation for Interior and Exterior Coating of Products, presented by Jeff Hale of Gema USA, Inc. Before we get started, I'd like to remind everyone that all attendees are on mute, so if you have any questions along the way, please type them in the questions panel. Jeff will address the questions at the end of the webinar. If we run out of time, there will be contact information on the closing slide if you have additional questions. This webinar is being recorded and will be available through the PCI store within 2 business days. All attendees will receive a brief survey after the webinar. Please take a few moments to reply. We appreciate your feedback as PCI continues to develop new programs to offer the topics and training you need. Now I'd like to introduce the presenter for today's webinar. Jeff Hale is the Marketing Director for Gema USA, Inc. He's an authorized speaker for PCI's Advanced and Basic Powder Coating Training Workshops. He has over 30 years of powder coating experience, and he's a presenter for Gema webinars and workshops. He has presented numerous times at PCI and other industry trade show and training events. Jeff, thank you for being here. I'll now turn it over to you.
Thank you, Kelly. Appreciate it. Welcome, everyone. Welcome to the webinar. So in terms of automation for interior and exterior coating of products, kind of a wide range of products that maybe come to mind when you hear the title like that. But we know that powder coatings really, in general, are applied to a wide variety of items. Many of these items require coatings to be applied both to the interior of the object, or maybe just only to the exterior, or a combination of both. Some items are very simple to coat. Others would be much more complex, and that really presents some challenges for manufacturers in trying to figure out how to put the best looking powder coating finish when they have objects that are requiring some challenging areas to coat. Operator training, so it's more than just maybe the coating thickness or appearance quality, but it might also be operator training, poor coverage in some of these recessed or exterior areas. So there's a variety of different things that challenge manufacturers as a whole. But I think what you'll find in looking as we watch through the presentation materials that I'm going to be providing you today, hopefully you'll see that there is a benefit to automation, and there's another level of automation that we'll talk about here shortly called dynamic contouring that really provides where the industry is looking for simplicity, reliability, and accuracy. Dynamic contouring is an automation technology that's really being utilized by a number of companies. It's easy to use. It eliminates complex programming, really, while improving productivity and coating appearance, as well as eliminating some or maybe all of the manual coating that might have traditionally been used. So as we go through the webinar, hopefully you'll see some advantages to this type of coating technology, an application or automation technology as it's being implemented within the industry. So as I mentioned, a lot of objects are being powder coated, and I think for those of us that have been in the industry a long time, we're a long ways from basic flat panels and simple sheet metal pieces. Today we're doing a lot more boxes, a lot more complex geometries, whether it's lawnmowers or toolboxes or trash bins or some sort of ductwork ventilation system. We're finding tractor components, large semi-trailers, and even cement mixers as examples of some of the large complex products that are on the market today, or are not really on the market, but are being coated in our market today. As we know, for years, traditional automation has been used, and that's traditionally been thought of as just a spray gun mounted on some sort of a stationary support stand, whether that would be a fixed applicator, or perhaps even more advanced of adding some sort of gun movement Regardless, most of the guns are fashioned in some sort of a traditional array, maybe a single column of guns on each side, or some combination of multiple columns of guns arranged in a configuration that allow the product to be coated. And so really the coverage was the coverage, or the ability to get the product covered, was dictated by how well you managed the application, how close the guns were, how far apart they were, and if they were moving up and down, the speed of that, and how did all that sync together. But that doesn't necessarily always lend itself to being able to get inside of exterior areas or move around the exterior shape of some complex geometries. So that presents a challenge for many of the applicators that have been doing powder coating, is how do we make those adjustments. Let's take a quick just a quick review of the types of gun movers that exist. We all understand that a stationary gun would be guns that are mounted on some sort of a stationary stand. The guns are permanently fixed into a position, and unless someone manually adjusts their position, they stay in that position. But with gun movers, we can move in multiple directions. Traditionally, the first object you see there it says Z-axis only on your screen. It's really talking about a gun mover that would move in the Z-axis, or what we call up-down movement. That's your typical reciprocation. Some people use the word oscillation, just depends on the type of mover that's being used, but it's gun movement in a vertical up-down direction. Likewise, you'll find a lot of companies are adding in some sort of in-out. So the X-axis is what we would call horizontal or in-out positioning, moving the gun out of the way as the products are coming down. Maybe you have wider or narrower objects moving along the line, and so the gun movement needs to be in or out. And then likewise, the last one is in the Y direction, in what we call along the axis of movement, or along with the conveyor. And in that particular case, we would consider that what's called tracking. So for some advanced applications, you might see one, two, or three of these axes being utilized in some method. But in most cases, as you can see, all of the guns would be moving in the same direction. So all the guns are moving up in the same direction at the same time. Likewise, the entire machine would be moving in and out at the same time, or tracking along the conveyor. Just as kind of an example, we'll take a little look at a movie. And here you can see a real short clip of something that's tracking along with the conveyor, moving up and down, and actually at the beginning, it actually moved in and out to position properly. But that would represent all three axes of movement: up, down, in and out, and tracking along the conveyor. Traditional gun moving, typical automation that has typically been used in the industry for a number of years. And in this case, because of how the product is presented, it's an excellent solution for getting up inside of a recessed area or a cavity that is consistently being presented to the guns on every part every time. And that in lies one of the challenges, is being able to have consistency of presentation, where the part is being presented in such a way that the guns can be programmed, or the machine can be programmed to repeat the coating motion as needed and at the speed needed. An alternative method that a lot of companies are exploring is really the use of robotic automation. And in the images on the screen that you see, you'll see a variety of different types of application. Maybe this is their primary method of coding. Maybe the requirements are that the robot has the capabilities to be able to handle the speed and the capacity of the products coming down the line. But regardless, we would utilize a spray gun that is mounted in a configuration that would have one gun, as you see on the screen, or in some cases, you might be able to use what we call a dual head applicator, where we would have the capability of doubling the traditional output out of a gun, because you're now using two spray guns, and being able to cover a product. One of the challenges with robotic applications is that it does require the programming to be completed so that the robot knows exactly where to position the product. And so as it's coming down the line, it must have some sort of program for each product style or each coating mode that you are needing to accomplish. Likewise, there is a limitation to the amount of movement that can occur. So we can really only move a robot so fast. One of the challenges with powder coating is that powder coating is a very slow coating method. So compared to a liquid application where the particle velocity being emitted from the spray gun is much greater in a liquid application, with powder coating it's much slower. So it is more susceptible to, as the gun is being moved, that we can move it too fast and deflect the spray pattern in such a way that would prohibit us from getting penetration or coverage. Likewise, you may have to, because of the square footage of amount of metal that we're having to coat, that it may be challenging to try and actually cover that with one or two guns, especially if we're trying to cover the entire product. So some applications lend themselves for the robot to be able to do that because of the way that the product is being presented, the speed at which it's moving past. And in other cases, it's not capable of coating the whole product, but could be utilized for strategic touch-up. Regardless, robotics are certainly a way to add another level of automation that would allow customers to be able to gain productivity and effective uniformity of coating and coverage, but it certainly has some of its challenges, as with any process. Here's a video that just kind of, if you've not seen a robotic application, real short little clip showing the gun being positioned inside for targeted coverage. And in this case, the line speed is very slow, allowing the robot to be able to coat all of the products from one side, and then a robot on the other side would handle the backside. So a typical robotic application in this example, where we're utilizing one applicator per robot. So what do we know about automation? So a lot of companies today are experiencing increased competition within their own industries. Manufacturers have competition from not only their peers in their marketplace, but maybe that's globally. And so the increased competition is to produce the products certainly at a lower cost with more efficiency. That is also then challenged by the complexity of the product. So our automation needs are evolving just as it relates to what the demands, the competitive demands are putting on a particular production facility, as well as the complexity of the product that they're trying to produce. We know that there's challenges from employees, not that the employees are challenging, but the challenges within a production facility are employee labor, finding not only the number of employees that would be needed to be able to operate the line, and in some cases where we're utilizing manual reinforcement for touching up, because we have significant amount of product square footage that we're trying to cover, and the automatic guns are not capable of producing 100% coverage. So you would add reinforcement. So having that type of skill set, we also know that increased, application precision. So the repeatability of that process, so that you can obtain not only consistent coverage, but repeatable from day to day. And so we know that really automation is requiring some new tools. There's things that are happening within our manufacturing environments that are really challenging us in our industry, and the equipment suppliers in the powder coating side of this have really kind of stepped up by offering some different tools. We established them earlier with traditional automation is one, adding robotics is another. But as I mentioned, we'll cover into dynamic contouring. That's another level of automation that I think from a new tool to answering that new tools required, it does a very good job. For a lot of companies, they're looking for ways to eliminate or reduce some of the programming challenges. Many companies have some sort of, as I mentioned, unique or complex shape that makes it difficult for them to be able to coat maybe some of their products, or just how they're going to manage that. Maybe it's the number of assemblies or unique SKUs or part numbers that they have, and it's growing. And so how do they manage that from a programmability standpoint? What kind of equipment do they have in process? Are they adding robotic applicators? And do they have the people to be able to manage the programming that's required with that? Or is that something that they would outsource? Certainly we know that just-in-time manufacturing presents some real challenges because we're not batching a lot of the products. So one part is coming down the line, and right behind it is a completely different piece, and that consistency is just rather random. And so multiple products that are being presented to the gun present some challenges. And of course, as we've mentioned, the labor issues that a lot of companies are facing in terms of just operator turnover and the continual training of how to be able to manually spray a product can be very challenging. That leads us to really a discussion on dynamic contouring. Dynamic contouring is kind of evolving as a coding name, much like you say robotic coating. Dynamic contouring is used by most of the major equipment manufacturers within the powder coating industry. So you'll hear that term, and really what we're talking about is contouring the product in a dynamic way. So dynamically meaning as it's kind of happening real time, the guns are moving into a different position to contour in and around or underneath or through the product that is being presented to the guns in some sort of manner that allows it to be coated effectively. To kind of help illustrate what that looks like, I'd like to show you a brief video. There's no sound or audio, but if you'll just watch the video, it's a nice animation that articulates really the concept of dynamic contouring. Having a problem with the screen. Oops, sorry. I think I hit screen share accidentally. I think it stopped sharing my screen. Give me just a moment. There we go. My apologies. See if that helps. I'm also going to turn off.
I can play the video directly if you need me to, Jeff.
Yeah, I don't. That's odd. Yeah, if you want to, James, let's go ahead and try that real quick. Can we stop sharing my screen?
Yeah, if you can stop sharing, I'll need to make myself presenter briefly.
There we go. All right. I'll click off of this, yeah.
And bear with me while I figure out which video it is. That one.
Yeah, apologize for the delay. We did have this working yesterday, but obviously today it's not.
You muted your mic or something.
All righty.
we made you the
Well,
presenter.
thank you for that, James. Appreciate the assistance. Let me turn my video back on and put us back here. Screen share, monitor 2. Is it not showing?
Yep, it's showing. You're good.
Yes, okay. So you should see the words dynamic contour on the screen there, and a picture of reciprocator with guns inside of a part there. So hopefully from the video you had a chance to actually be able to see that, and kind of through the animation get a little bit better idea of the kinds of things that dynamic contouring is intended to be able to be utilized with in terms of the complex geometry. Really, it's a fully automatic process that the equipment companies in our industry have developed to be able to get consistent results, increase the first pass efficiency by just being able to get the guns targeted closer to the surfaces that you're trying to apply powder to. So it reduces overspray. Obviously, that minimizes the amount of powder that we're consuming, gives you a powder savings. Each manufacturer is approaching their detection, if you will, in different ways. We're not all using the exact same tools, but we are using some sort of scanning technology that is designed to be able to look and take a digital image of the product as it's presented at the entrance of the booth. And the modularity is in a sense that, you know, we can add multiple scanners as products become more complex, and certainly even the size of the products can be expanded. Obviously, that all has to fit within the coating booth that you're utilizing the system in, but it does have the ability to be utilized on both small and very large products. Just to kind of, again, kind of walk through, you know, how does this process work? Let's just kind of describe what we saw in the video here in a little bit slower approach. So the first item that had to occur was we utilized the laser scanners to be able to take a picture, digitally scan the product as it is being presented to the scanners. And so that information is this digital image that is taken at the entrance of the booth. That information is then coupled with the data that we are acquiring, this 3D data generation, if you will, or the object that's the information about the object is presented along with the information from an encoder. So in this case, as the conveyor is moving at a particular speed, we're using a conveyor to track that movement. We're coupling and combining that with the digital information that we generated from the scanners. And in our case, we're passing it through our proprietary algorithms that we're utilizing in our software to be able to then position the individual guns. Either the entire machine is moving in and out, or the individual guns themselves. We call them what we call UA axis for the U direction. That's the independent individual gun movement. With any kind of part detection system you're utilizing in a powder coating system, there's been a variety that's been used over the years. Most people might be familiar with just a basic gap detection where we're looking for some sort of a gap. Is there a part there? Is there not a part? Maybe we've expanded to both height and width. So we're looking at not only the height, but we're also checking to see the width to move guns in and out. Those are the two most common methods that have been used for a number of years. An alternative method is using part identification using a QR code, maybe RFID, or even some sort of a code plate reader. In other words, the product is on a hanger, and the code, whether it's a QR code or the code plate, would have some sort of a number. The system would recognize that and identify that part as a specific item. But for dynamic contouring, we're utilizing 3D contour detection. Now, in this case, let me get there we go. What we're ultimately looking for in really all of these methods is some sort of control of either gun triggering or gun positioning. We may even want some stroke adjustment capability, and maybe even tie in some sort of gun setting, so adjusting the output. There's a variety of different things that can be done with one or multiples of these types of detection systems, but we have to be able to identify the part to be able to automate in some way or adjust parameters around the application. For dynamic contouring, we're utilizing this contour detection as a way to help us to reduce the overspray, achieve some powder savings, and improve coating quality. To help articulate kind of how that process works, let me show you this little video here. This should play relatively easily, and as you should be seeing some red lines appearing on the screen, and that is one scanner taking a look at an object. But as you can see, there's a gray area that appears because the beams could not see some recessed area. So by adding, in this case, a second scanner, we can get a much better image of the shape of the object, and at that point, that establishes a kind of a coating path. As we bring in the automatic guns, you will see that gun number 1 and 2, they're in segment 1 and 2 up at the top, actually have a slightly different position than the other guns below them, as the first 2 guns are being positioned closer to the curvilinear shape of the interior of this object. And that's really how dynamic contouring is working. As that shape is adjusting or changing, each one of these guns would then move in or out to correspond to the image that the scanners were able to identify in the scanning process. So when we talk about 1 or 2 scanners, in this particular case, the gray area that you see on the image on the left side of the screen, that is a shaded area that the scanner was unable to identify. And so by adding the second scanner, we're able to really visualize the interior of that. And again, as I mentioned, get a much better get a much better digital picture of what this product looks like. And then the gun adjusts based on the parameters that you've set in terms of target distance and so forth, to be able to maintain that appropriate target distance as it identifies the shape. With dynamic contouring, there are some really nice advantages. As I mentioned, certainly the programmability, not having to really program the guns for whatever product or shape is presented. The scanners are determining the shape of the object, and the guns are then adjusting based on that shape or digital image. But we do have the ability to travel at relatively high line speeds. As you can imagine, the faster we go, the harder it is for something to be digitally imaged. And so today we're seeing line speeds that are around the 5 meters a minute. Let's call that somewhere in the 15 to 17 feet per minute. And then as far as the shape or the how thin of an object can we actually detect, that's going to vary by the various manufacturers in terms of what their equipment is capable of doing. But in general, I think you would find that we're certainly at 10 millimeters. Certainly, there are systems out there that are capable of as low as 10 millimeters on the depth, and as high or as thick as 5 millimeters in the along the direction of travel. So you do have the ability to detect some relatively thin edges or profiles, which helps. And so that helps us to be able to get movement around different protruding objects, or even movement into a recessed area if it can be achieved based on the line speed that you're traveling. So we talk about the tools. The spray gun is the same spray gun that we would use in any powder coating application. It's mounted on a gun bar and a positioning device. As you see above the reciprocator or gun mover, you see this long, the gun mounted to what looks like a very long shaft or lance or whatever you would like to call it, but it is in this case, the gun axis mover. And the gun is connected to a plastic tube, a fiberglass reinforced tube that allows the gun to be moved so that the gun mover kind of stays in a fixed position, but it's moving or lancing out the gun bar with the gun on the end of it for its movement. And so we do have the ability for precise movement in terms of automating for a complex shape. You can use this to help reduce or eliminate any kind of manual touch-up that might be required for the application. The speed at which it moves, the in and out speed, is very high speed, so it gives us the ability, as I say, as I was mentioning in the previous slide, for line speeds even up as high as 15 to 17 feet a minute, you still have the ability to move a gun in and out, so we're getting a very fast responsiveness. And of course, the precise location of the gun. So each gun is then independently controlled. So that allows us a little bit more precision coating, application of the coating by having each gun independent from one another. And then obviously we can put some sort of a cleaning mechanism that allows the gun to be cleaned off as it's retracting in or out, so that we keep the powder in the booth and keeping that a minimal amount of material that we have to worry about as the gun is being used. The reciprocator that's being used, each of the manufacturers in our marketplace today have some sort of a gun mover or stand that is used. Not all of the applications move up and down, but I would say the majority are utilizing gun movement up and down to be able to work in conjunction with the dynamic contouring, the UA axes independent gun movers. But in this case, the gun mover has to be designed to be able to handle a higher weight load. Obviously, with the gun mover, the in-out positioning movement of the gun axis adds some weight to the machine. So it has to be appropriately designed for the wear and weight restrictions, not restrictions, but the weight that would be added on over and above what you would traditionally see with a typical gun mover with just you know, 1, 2, 8, 10, whatever the number of guns are that you would mount on gun bar. So it does have to have some ability to be able to stand from the durability standpoint, reliability, ease of motion, electronic. These machines are AC motors, so they're belt driven. That allows them to be able to have great reliability and ease of maintenance, as well as the type of motion. Being electric and reciprocating motors allows the units to reciprocate up and down very easily with a minimal amount of delay at the up and down, at the top and bottom of the stroke. And the guns can be mounted or configured in a number of different methods, like you see on the screen. You see kind of 3 different views where the guns are all on, say, the left side, then all on the right side, or maybe even on both sides. It just depends on the type of application. So what is dynamic contouring? Well, it's a way to really improve the application consistency. It allows us to be able to code a product automatically, adapt to the various products that are being presented, no special programming required. And certainly one of the key one of the key reasons that we're using that is to increase the coverage that is being applied or achieved by utilizing automated guns, so that you're reducing any kind of manual touch-up. So we achieve greater consistency, repeatability, and performance by utilizing the automatic guns, really trying to increase our first pass transfer efficiency. So it's a very effective way for a lot of very complex shapes to be powder coated much more easily and conveniently and at higher production rates than what could be achieved in previous methods, without all, and certainly without all the complexity associated with programming. Now, there are always going to be some applications where maybe the dynamic contouring doesn't get it all, but it certainly improves the coverage. And so then the question is, okay, for those very strategic areas where there is still a coating required and was not capable of being achieved with dynamic contouring, you will find some companies that are coupling a robotic applicator onto the process. And much like you see in the image on the screen, you'll see the dynamic contouring reciprocator with the guns protruding into the booth cabin. And then at the other end of the booth, you'll see what looks like a green robot dressed in a white covering, and that has a robotic gun on the end of it, and that would be used for strategic touch-up on some of the items. So there are applications where we're combining this technology, the 2 technologies, robotic applications and dynamic contouring, but many of them are just traditionally dynamic contouring by themselves. I'd like to leave you, if this video doesn't play very well, we'll see how this plays. I'd just like to leave you one final video as we bring this to a close that kind of helps to show you some examples of products being coated. This is not an animation, but actual video of products being coated. So hopefully this plays well and you'll get an idea of dynamic contouring. So hopefully that gives you an idea of dynamic contouring as a very effective tool that's being utilized by our industry as a way to automate very complex shapes or applications where there is an opportunity to eliminate or reduce manual touch-up. Any of those applications would be potentially an ideal candidate for dynamic contouring. At this point, that's all of the materials that I wanted to review. So I'll at least open up the floor for some questions. If there are some, be more than happy to try and answer some of your questions.
If anybody does have a question, you should be able to submit a question through the question box. Please do so now. I'll give everybody another 30 seconds to a minute.
I'm not seeing any in the chat. Not sure if there were any that were submitted.
Nothing was submitted earlier, no. You covered your topic very well. Still nothing, so if you want to continue to the last couple
James,
announcements.
if you're talking, I'm not hearing it.
Yes, I am.
Okay, well, if there are none, if you do have some questions, as was mentioned in the opening, there's information on the last slide here. You can be more than happy to try and answer them afterwards. Feel free to submit your questions to PCI. As a final couple comments here, I'll go back to the presentation. For those of you that are not familiar, Powder Coated Tough magazine is a great way for you to gather information about our industry. And so if you've not subscribed to Powder Coating Tough, either the print or digital editions, I would encourage you to do so. It's a great resource for our industry. Lots of good information about all things powder coating. It's the industry Powder Coating Institute's main publication, only publication, but it's dedicated to powder. So it's a great tool for us to be utilizing if we're looking for information. Of course, they do have their buyer's guide and then the issues that are released each year. I think there's 5 or 6 issues, including the 6, including the buyer's guide. So hopefully you get an opportunity to read through that if you haven't already. One other note is that new is the Spanish version of Powder Coated Tough. And if you would like to subscribe to that, you can also reach out to the powdercoatedtough.com to either subscribe to the traditional Powder Coated Tough or the Spanish version, Espanol. And certainly encourage you, for those that have an interest in that, please sign up for that. And without any further ado, I'll thank you very much for the opportunity to speak with you, and I'll turn the program over to PCI.
Thank you, Jeff. Thank you for being here. Thank you to all for attending this webinar. Don't forget to check out Powder Coated Tough magazine online and subscribe today. Please watch for a link to the survey and take a few minutes to give us your feedback. And everybody, have a great day.